Okay, welcome America, welcome India, and welcome Taylor Swift. On this Valentine's Day, we are doing a live studio recording in Studio 212. We're going to do a quick review on the sum of the interior angles of polygons and also the exterior angles, okay? So the sum of any, all the interior angles inside any triangle is 180 degrees. Now, if I take a quadrilateral, which is a four-sided figure, and I figure out how many diagonals can I draw? We've got one, which cuts the quadrilateral up into two triangles. Each of those triangles have 180 degrees, right, for the sum of those interior angles, which means that the sum of all the interior angles in any quadrilateral four-sided figure, rectangle, a kite, a parallelogram, is always 360 degrees, and it's 180 times 2. So it's the number of triangles times 180. So now, let's look at the next example. We've got a pentagon. Pentagon has 3 triangles inside. Each of those triangles have 180 degrees. So the sum of all the interior angles in any pentagon is the number of sides minus 2, which gives us the number of triangles, which is 3 triangles, times 180. Each are 180 degrees. 180 degrees, 180 degrees, 180 degrees, 180 degrees times 3 gives us 540 total degrees. All the interior angles of a pentagon, any pentagon. So now we've got a hexagon. You can create 4 triangles in a hexagon. Noticing a pattern here, it's the number of sides. Come on now. The number of sides minus 2 gives us the number of triangles, which in this case is 4. And there are 180 degrees in each of those triangles, so it's 4 times 180. And I think this is 720. So, last but not least, here's the formula. N minus 2 times 180, that will not be on any formula sheet. It's not on a formula sheet for the SOL. You just have to know it, and you'll need it in vector calculus. Sometimes they call it multivariable calculus. That's the calculus class that you'll be taking after like Calc 1, 101, 102, or Calc A, B, and BC. So it's third year, or semester, I should say. All right, so the last thing I want to talk to you about for the same concept when we're talking about all the sum of all the interior angles in a pentagon is if we have a regular pentagon, which means all the sides and angles are the same. Oh my gosh, we can just take this, how many ever there are, and divide by how many there are. Oh my gosh, I am not speaking well today. My class is laughing at me as they're being very quiet. So this is the pentagon. We've already figured out that the sum of all those interior angles is 540 degrees, right? So 540 degrees. And this one, it's regular, so they're all the same. All 5 are the same. So you just take the sum and divide by how many there are. In this case, there's 5, okay? Now, let's move on to exterior. Exterior angles, this was a quadrilateral. Okay, you can see the exterior angles of any polygon add up to 360 to create a circle. The next one is a pentagon, but notice, different number of sides, but still the exterior angles still add up to 360 degrees because there are 360 degrees in any circle. So you don't have to worry about the number of sides whenever you get a polygon. If you need to know the sum of the exterior angles, it's just going to be 360. And then of course, if you have a regular polygon, the sum is 360. If you need to figure out the measure of one of them, you can just take 360 and divide by, oh my gosh, 5, how many ever there are. So in this case, it's 360 divided by 5 will give you the measure of each one of these, and I think this is 72. Now, of course, I didn't show this to the class, but if you would like to figure out the interior angle, you could, this is a straight line, right? You could do 180 minus 72, and that will give you the measure of the interior angle,